smart on something important, fast, but thoroughly. That's kind of the sweet spot we're aiming for.
Yeah, that's the goal.
And that's exactly what this deep dive is designed to deliver, your personal shortcut to really understanding artificial intelligence. It's a field that's, well, it's moving incredibly fast.
It really is. Warp speed almost.
Let's be real, the amount of news, the information around AI, it's just overwhelming.
Totally. It's hard to keep up.
So our mission today, really zero in on what truly matters, the core insights you need to grasp this complex landscape.
Absolutely. There's so much hype, so much jargon flying around, getting a clear, grounded understanding. That can feel like a real challenge. This
Yeah.
is about cutting through all that noise.
And our roadmap for this is a document called the AI Horizon. It's pretty comprehensive, taking us from the fundamental principles right through to its almost sci-fi potential
Right.
and the very real impact it's having right now.
The AI horizon really does give you that 360-degree view.
Yeah.
It lays a strong foundation, definitions, core tech, explores the different kinds of AI we're seeing or might see. And then it dives into real examples, how it's used across industries.
And importantly, it looks at the future too,
Mm.
right? And the risks, governance, all that critical stuff.
Exactly. It covers the whole spectrum.
So by the end of our conversation, you listening should have a really solid foundational understanding of AI, where it is today, where it might be going.
Without getting totally buried in technical jargon, hopefully.
That's the idea. We're after those aha moments, those surprising facts that stick with you, a clear sense of what's truly significant. Okay, let's dive in. Defining AI. It's got to be more than just clever computer tricks, yeah.
Oh, absolutely. The core concept, as the AI Horizon lays it out, is really about creating computer systems that can do tasks that, well, historically required human intelligence.
Like what kind of tasks?
Think about things we associate with being smart. Learning from experience, understanding language, spotting patterns, reasoning through problems, making decisions, that kind of stuff. It's the whole effort to replicate those cognitive functions in machines.
And this isn't exactly a brand new idea, is it? The document points out the term artificial intelligence actually goes way back to 1955.
That's right. John McCarthy, one of the pioneers in computer science, he coined the term, and his initial definition was pretty straightforward: the science and engineering of making intelligent machines.
Simple enough.
What's really interesting, though, is how the focus has shifted over time. Early AI often tried to, program intelligence directly, writing code rule by rule to mimic thinking.
Ah, okay.
But the main approach today, it's much more about enabling machines to learn from huge amounts of data, kind of like how we learn.
Which leads to this idea of software 2.0, doesn't it? What does that actually mean?
Yeah, Software 2.0 really captures that big shift. It's moving away from those old rule-based systems,
Yeah.
Where a programmer wrote every single instruction, that's Software 1.0,
Yeah.
towards these data-driven systems. So in this new way, the AI's abilities aren't directly programmed in detail. They sort of emerge from analyzing massive data sets.
Yeah.
It's the difference between, say, telling a computer exactly how to recognize a cat, step by step, versus showing it millions of cat pictures and letting it figure out the defining features for itself. Learning from examples.
So fundamentally, it's about processing information, finding patterns, and the document mentions algorithms and AI models. How do they fit in?
Right. So algorithms are basically the step-by-step instructions the computer follows. For any task, really. In AI, they're crucial for processing data, for the learning part, and then for making predictions or decisions based on that learning.
Got it. Algorithms are the instructions and models.
The AI model. Think of that as the result. It's the mathematical representation, the sort of distilled knowledge that gets created when you train an algorithm on data. That trained model is what you then use to analyze new stuff and generate outputs.
Okay, algorithms are like the recipe. The model is the cake you baked, and you can use the cake to do things.
That's a pretty good analogy, actually. Yeah.
And the AI Horizon really emphasizes this idea that AI could become a foundational technology, like electricity or the internet. That sounds huge.
It is a huge claim, but it reflects the potential.
Hmm.
AI isn't just about transforming how society works. It could drive breakthroughs in almost every other field of science, too. It's not just another gadget. It could be woven into the very fabric of everything.
Right. Okay, so that's a good handle on what AI is. Now let's look under the hood a bit. The building blocks. The AI Horizon breaks down these core AI technologies. First one, machine learning, ML. Sounds pretty central.
Absolutely critical.
Yeah.
Yeah, machine learning is a key subset of AI. The main idea is equipping systems with the ability to learn from data and get better at tasks without needing explicit programming for every single step.
So no predefined rules for everything.
Exactly. Instead, ML algorithms find patterns in the data itself to make predictions or decisions.
So it's learning by doing, almost, by seeing examples.
Precisely. And the AI Horizon outlines a few key approaches within ML. The first one is supervised learning. How does that work?
Okay, supervised learning here. The algorithms learn from data that's already labeled. So imagine feeding the AI pictures, and each one has a tag: cat, dog, car.
Right.
The goal is for the AI to learn the connection between the picture and the label so it can then identify new pictures it hasn't seen before.
Makes sense. Label examples. Then there's unsupervised learning. That's different, isn't it?
Yeah, completely different. With unsupervised learning, the AI gets data with no labels.
Right.
It's like dumping a huge box of photos in front of it and saying, okay, figure out if there are any natural groups or patterns here.
So it's finding hidden structures on its own.
Exactly, no prior guidance.
Yeah.
Then you've got reinforcement learning. This always makes me think of training a dog or something.
It's actually a really good analogy. So in reinforcement learning, you have an agent, the AI learning by interacting with an environment.
How does it learn?
It takes actions, and then it gets feedback, rewards, or penalties. The goal is to learn the sequence of actions that gets the biggest total reward over time. Think AI playing games, or robots learning to walk. Okay.
Trial and error with rewards. And the last one mentioned is self-supervised learning. This sounds newer, more complex.
It is a bit newer and very powerful. With self-supervised learning, the AI models basically generate their own labels from the massive amounts of unlabeled data they see.
How does that work?
It might, for example, take a sentence, hide a word, and then try to predict the missing word based on the context. It creates its own learning task. This is super useful for things like natural language processing, where labeling huge text data sets by hand would be, well, practically impossible.
Right. Okay, that covers the main types of machine learning. Now, deep learning. The document calls it a specialized subset of ML, inspired by the brain.
That's the idea. Deep learning uses artificial neural networks, or ANNs, with multiple layers. The deep just refers to having many layers, not necessarily profound thought.
Okay, multiple layers.
These networks are made of interconnected nodes, sort of like artificial neurons, arranged in these layers. And deep learning models, especially the really deep ones, are incredibly good at handling large, complex data sets. That's why they shine in things like image recognition or understanding natural language.
So each layer finds more complex patterns.
Kind of. You can think of it like a complex filter system. Each layer progressively extracts more abstract features from the raw input data, building up until the AI can understand the underlying patterns.
And getting these models to work involves training, right?
Exactly. Training is crucial. It's the process where you adjust the connections, the parameters within that neural network based on the training data you feed it, like fine-tuning all those little connections to get the best performance on whatever task you want it to do.
And the data itself is key here.
Absolutely critical.
Yeah.
As the document stresses, the quality and just the sheer quantity of training data fundamentally determine what that AI model can ultimately do. Garbage in, garbage out, basically.
Makes sense. And all that raw data needs to be usable by the model. Feature extraction.
Right. Feature extraction is about identifying and transforming the raw data into meaningful attributes the model can actually learn from. But one of the really powerful things about deep learning is that it often automates a lot of this feature extraction.
Oh, that's handy.
Yeah, in older ML methods, figuring out the right features could be a huge, time-consuming part of the job. Deep learning often learns the important features itself directly from the data.
Okay, so putting it together, AI is the big umbrella. Inside that, machine learning is about learning from data. And deep learning is a type of ML using these multi-layered neural networks. Got it. Now, natural language processing, NLP, this is about computers and human language.
Precisely. NLP is that vital bridge. It lets computers understand, interpret, respond to, and even generate human language. It combines ideas from computational linguistics, the rules and structure of language, with ML and deep learning algorithms trained on just vast amounts of text and speech. And the document highlights how deep learning, especially things called transformer architectures, like the GPT models everyone's heard of, have just revolutionized NLP. They can grasp context, even subtlety, much better.
And NLP has two main sides, right? Understanding and generating.
Yeah, basically.
Yeah.
Natural language understanding, NLU, is about the machine comprehending language, the meaning, the intent behind it. And natural language generation, NLG, is about the machine producing human-like text or speech.
And there are specific techniques used underneath all
Oh
this.
yeah, lots of them. Things like tokenization, breaking text into smaller bits, like words or parts of words, stemming and lemmatization, getting words down to their root form, removing common stop words like the or is,
Mm,
figuring out sentence boundaries.
okay.
And the document also mentions things like recurrent neural networks, RNNs. Since language is sequential, words come one after another.
Right.
RNNs have a kind of memory that lets them consider previous words when processing the current one. That context is key for language.
And this powers so much stuff we use daily. Virtual assistants, chatbots, translation.
Sentiment analysis, content moderation on social media,
Yeah.
loads of applications.
Exactly. Okay, the final core tech mentioned is computer vision, getting machines to see.
That's the one. Computer vision gives machines the ability to interpret the visual world images, videos. It involves taking that visual input, turning it into digital data the computer can work with, and then making decisions based on what it sees.
And the document lists key applications like classifying images, facial detection, and recognition.
Object recognition, analyzing medical scans, even recognizing activities happening in videos. Lots of areas.
So what really stands out, as the AI Horizon points out, is that these technologies aren't separate silos. They're all interconnected.
Deeply interconnected, yeah. AI is the broad field, ML gives the learning mechanism, DL is a powerful set of techniques within ML. The NLP and computer vision are key areas where you apply ML and DL to language and visual data.
And progress in one area often pushes the others forward.
Absolutely. An advance in deep learning can suddenly unlock new capabilities in NLP or computer vision. It's that synergy that's driving a lot of the rapid progress we're seeing.
Okay, that gives us a great map of the core technologies. Now let's talk about the AI spectrum. The document describes different levels of AI, from really specific systems to, well, stuff that's still hypothetical.
Yes, it's helpful to think of AI existing on this continuum of capability and generality.
Mm-hmm.
We start with artificial narrow intelligence, ANI, also often called weak AI.
And that's basically all the AI we actually have today, right?
Pretty much, yeah. ANI is designed and trained for one specific task, or maybe a narrow set of tasks, within a very defined area.
So it can be superhuman at that one thing.
Often, yes. Think about an AI that plays chess incredibly well, or a really accurate facial recognition system.
Hmm.
They can outperform humans in their narrow domain,
Mm.
but they lack general cognitive abilities. They can't apply their intelligence outside what they were trained for.
So the examples you mentioned earlier, Siri, Alexa, recommendation engines, spam filters, they're all ANI.
Exactly. They operate based on their training data and algorithms. They simulate intelligent behavior within those set boundaries, but there's no real understanding or consciousness there.
And the document even breaks ANI down further based on memory.
Right. It mentions reactive machines, no memory of the past, just reacting to the present like IBM's Deep Blue chess computer.
Hmm.
And then limited memory AI, which is most modern AI, including deep learning. They can use past data for a short time to inform current decisions.
Okay, so that's the current state of play. Now, a category that's gotten huge attention lately, generative AI.
Yes, this is the AI that can create new original content. Text, images, audio, code, video,
Mm.
content that resembles the data it was trained on.
How does it typically work?
Often involves training these enormous foundation models on just massive data sets. Then you can fine-tune those models for specific tasks. We've seen incredibly powerful large language models, LLMs, like the GPT series, PaLM, Gemini. They're amazing at understanding, summarizing, translating, generating really human-like language.
And models like ChatGPT have definitely captured the public imagination, made advanced AI feel closer somehow.
For sure.
But the document still classifies them as narrow AI. That might surprise some people.
It's a really crucial distinction. While these generative models have incredible abilities and can be applied broadly, their core function is still specific, generating content based on learned patterns.
So they're versatile, but not truly intelligent in a general sense.
Right. They don't have the general intelligence to truly understand or adapt to completely new situations like a human can. They're still operating within the confines of their training, even if those confines are very wide.
Okay, that clarifies things. Now, the big one, the sci-fi staple. Artificial General Intelligence, AGI, also called strong AI or human-level AI.
Exactly. AGI is that hypothetical future stage, a machine with cognitive abilities comparable to, or maybe even better than, humans across a wide range of intellectual tasks.
So, unlike ANI specialization,
Right? AGI would be able to understand, learn, reason, plan, solve novel problems, think abstractly, adapt. generalized knowledge across different domains without needing specific programming for every single new thing.
And the key point, no true AGI exists right now.
Not even close, really.
Yeah.
The document also mentions the philosophical debate. The strong AI hypothesis, could AGI actually be conscious? Versus the weak AI hypothesis, is it just a very convincing simulation?
Interesting. And people are already thinking about how to classify AGI if it did arrive.
Yeah, researchers are proposing frameworks, trying to define levels of AGI based on performance and autonomy compared to humans.
Okay. And then even beyond AGI, there's artificial superintelligence, ASI. That sounds intense.
It is. ASI is the hypothetical AI whose intelligence would just vastly surpass even the most gifted humans. In basically every field imaginable, science, wisdom, social skills, you name it, it's the stage beyond AGI.
And the document brings up this idea of recursive self-improvement, potentially leading to a very rapid jump from AGI to ASI.
That's a major point of discussion and concern. The idea is that an AGI could start improving its own intelligence.
Uh-huh.
And that could create a positive feedback loop, leading to this accelerating, maybe uncontrollable growth and capability.
Yeah.
An intelligence explosion.
And that's linked to the technological singularity.
Often, yes. The singularity is that hypothetical point where technological progress becomes so fast and profound that the future becomes, well, fundamentally unpredictable and irreversible.
Wow. Okay, so generative AI, while still narrow AI, has maybe made AGI seem more plausible to people?
I think that's fair to say. It's demonstrated such a breadth of capability, language, coding, even some basic reasoning, that it's definitely fueled speculation and research towards AGI. It makes the idea feel more tangible.
But we need to remember the limitations.
Absolutely. It's crucial. Generative AI still works mostly by pattern matching. It lacks deep understanding, real adaptability, the autonomous learning we'd expect from true AGI. So it's a huge step, but there's still massive challenges ahead to bridge that gap.
Right, okay. Spectrum mapped out. Now let's get concrete. AI in action. Where is it actually being used today and making a difference? The AI horizon goes through several industries. Let's start with healthcare. Seems like a huge area for AI.
It really is. AI is fundamentally changing things across the board in healthcare. Diagnostics, drug discovery, personalized treatments, even just making hospitals run more efficiently.
The document highlights analyzing medical images, X-rays, CT scans, MRIs. How is that helping?
AI algorithms are getting incredibly good at spotting subtle patterns or anomalies in those images, things that might indicate cancer or diabetic retinopathy or pneumonia, often with amazing speed and accuracy.
Better than human radiologists sometimes.
In some specific tasks, yes. There are studies showing AI catching things humans missed. It can lead to earlier diagnosis, fewer errors, better outcomes, and you see the FDA approving more and more AI-powered medical devices, which shows it's becoming mainstream.
And it's not just images, right? Drug R&D, that's usually a super long process. AI is speeding that up.
Massively. Machine learning can analyze huge biological and chemical data sets to pinpoint promising drug candidates, predict how effective they might be. Think of DeepMind's AlphaFold, predicting protein structures. That's huge for understanding diseases and designing drugs. It's already helped with things like malaria vaccine development.
Wow.
AI is also helping optimize clinical trials, finding the right patients, figuring out dosages, spotting potential side effects earlier. Companies like Benevolent AI are built around this.
That's incredible. And personalized medicine, tailoring treatments to individuals.
AI is key there too. By analyzing a patient's specific data, genetics, lifestyle, medical history, maybe data from wearables. AI can help doctors tailor treatment plans much more precisely. That could make treatments way more effective.
And behind the scenes, helping with the admin burden.
Exactly. AI tools can automate writing clinical notes, summarizing patient visits, managing electronic health records, freeing up doctors and nurses to spend more time with patients.
That sounds like a welcome change.
Plus, you have AI chatbots answering basic questions, scheduling appointments, AI helping with remote patient monitoring through wearables, even robots assisting in surgery or handling logistics in hospitals like Moxie.
And the document mentions accessibility too, getting healthcare to more people.
Yes, that's a huge potential benefit. Using AI for telemedicine for AI-assisted diagnostics in remote or underserved areas where specialists might not be available, it could really help bridge gaps in care.
So it sounds like in healthcare, AI is mostly acting as a really powerful assistant for human professionals, augmenting them.
That's definitely the primary role right now, enhancing
Yes.
efficiency, accuracy, letting them do more. It's not about replacing doctors, but empowering them.
Okay, let's switch to another big one, finance and fintech. AI seems like a natural fit there.
Oh, absolutely. The finance world runs on data, and AI is brilliant at processing data. It's become a foundational tool for efficiency, automation, making smarter decisions in banking, investing, insurance. The AI and fintech market is huge and growing fast.
A big application is fraud detection, right? Stopping bad actors.
Precisely. AI algorithms are great at scanning massive amounts of transaction data in real time, looking for weird patterns that signal fraud, identity theft, account takeovers, that kind of thing.
And they're better than older systems.
Much better, especially because ML models can learn and adapt. Old rule-based systems are static. Fraudsters figure them out. AI can keep up with new tactics.
Saves a lot of money and hassle, I bet. What about algorithmic trading? AI making stock market moves?
Yep. AI models analyze incredibly complex data market trends, news sentiment, economic indicators way faster than any human could. They can execute high-frequency trades at just the right microsecond to capitalize on tiny market movements.
High-speed decision-making. And getting loans. AI is changing credit risk assessment, too.
Definitely. Traditional credit scores often use limited data. AI can look at a much wider range of factors, sometimes called alternative data, to get a more accurate picture of someone's creditworthiness.
So potentially fairer decisions, or maybe opening up credit to people missed before.
That's the hope, yeah. Companies like Zest AI are working on that, making lending decisions more nuanced and potentially more inclusive.
It seems like AI is everywhere in finance. Robo-advisors giving investment advice, chatbots handling customer service.
Enhancing blockchain security, improving data quality, automating financial reporting. It touches almost everything.
And it works so well because finance just generates so much data.
Exactly. And AI, especially ML and deep learning, provides the tools to crunch that data at scale, find patterns, predict risks, make operations more efficient. Of course, with all that sensitive financial data.
Privacy and security are huge concerns.
Absolutely paramount. Can't mess around with that.
Right. Okay, let's shift gears again. Transportation. Self-driving cars get all the headlines, but AI's impact seems broader.
It really is. AI is fundamentally reshaping the whole transport system, from the vehicles themselves to how we manage traffic and logistics.
So let's start with those autonomous vehicles, AVs. What's the role of AI there?
AVs are packed with AI. Computer vision to see the road, sensor fusion to combine data from cameras, LiDAR, radar, machine learning to understand and predict what pedestrians or other cars might do, path planning algorithms to navigate.
Companies like Tesla, Waymo?
They're the big names, yeah. Full self-driving everywhere, all the time. Still a work in progress, a major challenge. But the AI-powered driver assistance systems, ADAs, are already common in new cars. Lane keeping, adaptive cruise control.
That's a stepping stone.
Exactly. And the potential benefits of full autonomy are huge. Safety, less traffic, fuel efficiency, mobility for people who can't drive. Projections for adoption vary, but it's coming.
And beyond the car itself, optimizing the whole network.
Yeah, intelligent traffic management systems. Using AI to analyze real-time data from cameras, sensors, then dynamically adjusting traffic lights, predicting jams, suggesting better routes to drivers via navigation apps.
Like in Los Angeles, they have smart traffic lights, right?
They do, yeah. Trying to ease that infamous congestion. They can make a real difference in reducing travel times.
In logistics, moving stuff around, supply chains.
Big impact there, too. AI optimizes delivery routes for companies like UPS and DHL, manages vehicle fleets tracking, driver performance, predicting when a truck needs maintenance, forecasting demand for goods so warehouses have the right stock.
Automating warehouses, too?
Yep, using robotics and computer vision for sorting and moving packages. And we're starting to see autonomous freight transport, self-driving trucks, delivery drones. The AI and logistics market is set to boom.
So AI isn't just about the individual vehicle, it's about system-level optimization, making the whole transportation network smarter.
Exactly. Integrating all these different data sources. But it requires things like good data sharing protocols, V2X, vehicle-to-everything communication, plus infrastructure upgrades and clear regulations to make it all work together smoothly and safely.
Makes sense. Okay, let's pivot to something maybe a bit lighter. Entertainment, media, and gaming. How's AI changing things there?
Primarily through hyper-personalization, and increasingly helping actually create content. The market for AI here is growing really fast, too.
Hyper-personalization.
Yep.
So like when Netflix or Spotify suggests things I might like, that's AI.
Absolutely. They analyze huge amounts of data about what you watch, what you listen to, what you skip, what time you engage, plus data from millions of other users to build a profile and recommend content specifically tailored to keep you engaged, keep you subscribed, keep you watching ads, TikTok's algorithm is famously good at this.
It definitely knows how to keep you scrolling. And in gaming, what's AI doing there?
Lots of things. Adjusting game difficulty on the fly based on how well you're playing. Personalizing rewards, making non-player characters, NPCs, seem more realistic and react intelligently.
Like they're actually thinking.
Well, simulating thinking very effectively.
Yeah.
Also, procedural content generation, PCG, AI creating game levels, items, even whole worlds automatically, like in No Man's Sky.
Right, Infinite Planet.
AI upscaling graphics to look better, like NVIDIA's DLSS tech. Modeling player experience to adapt gameplay. Analyzing player data for insights, or detecting cheating. Even generative AI creating interactive stories, like AI Dungeon 2, using GPT models for basically infinite text adventures.
And AI is helping create content outside of games, too.
Yes, generating basic news reports from data feeds, composing music, assisting writers, automating parts of video editing, content moderation, spotting harmful stuff online, detecting plagiarism or fake news, analyzing audience reactions, even automating parts of sports broadcasting.
So AI is kind of the engagement engine in media and entertainment, figuring out what we like and giving us more of it.
That's a good way to put it.
All right.
But as the AI Horizon note, that raises ethical questions. Are we being manipulated? Are filter bubbles making us more polarized? What about addiction, mental well-being, informed public debate? These are serious considerations.
Definitely food for thought. Okay, let's bring it even closer to home. AI in our daily life. It feels like it's seeping into everything.
It really is, often quite subtly. The main drivers are convenience, automating boring tasks, and that personalization we just talked about.
Like the virtual assistants on our phones or smart speakers. Alexa, Siri, Google Assistant.
Exactly. They use NLP and ML to understand voice commands, do tasks, answer questions, and they learn your preferences over time to get better, more personalized. We're even seeing specialized AI assistants just for scheduling meetings, like Calendly or Reclaim.ai.
And the whole smart home idea relies heavily on AI, right?
Totally. Smart thermostats like Nest learn your heating and cooling habits. Smart lighting adjusts automatically. AI-powered security systems detect unusual activity. Even smart fridges that track inventory and suggest recipes. That's AI working behind the scenes to automate and optimize your home environment.
And online. When we search or use social media.
AI is constantly working there. Search engines like Google use AI RankBrain was an early example to better understand what you're looking for, not just the keywords you typed. Social media feeds are curated by AI to show you content it thinks you'll engage with. E-commerce sites like Amazon use AI for those product recommendations.
It's almost invisible sometimes. What other everyday tools use AI?
Your email client probably.
No.
Spam filtering is heavily AI-driven now, smart replies. Navigation apps like Waze or Google Maps use AI to analyze real-time traffic and find the best routes. Ride-sharing apps use it for dynamic pricing, matching drivers and riders, predicting ETAs. Language translation apps, weather forecasting, even wearable health trackers analyzing your activity and sleep.
So AI in daily life is like this invisible hand, making things smoother, more efficient, more personalized.
Largely, yes, driven by convenience. But again, the document raises the privacy flag. All this personalization relies on collecting and analyzing huge amounts of our personal data.
Often without us fully realizing it.
Exactly, and that raises big questions about data security, potential misuse, and how much algorithmic influence we want, shaping our choices without us even being aware of it.
Right. Okay, one last area of AI in action from the document. Accelerating scientific discovery. This sounds incredibly exciting.
It really is. AI is becoming a transformative tool for scientists.
Yeah.
Helping them analyze data sets that are just too massive for humans to handle, spotting patterns no one saw before, even generating new hypotheses to test.
Can you give some examples across different fields?
Sure. In biology and medicine, like we touched on, analyzing scans, interpreting complex genomic data, predicting protein structures with AlphaFold, identifying potential drug candidates, even analyzing cell images for diseases like Alzheimer's.
Okay. What about other sciences?
In chemistry and material science, AI helps interpret molecular structures, predict properties of new materials, think better batteries, stronger alloys, more efficient catalysts. There are even autonomous labs, like A-Lab, using AI to discover materials. In physics, analyzing particle collider data to find new particles or patterns.
Climate science.
Definitely. Processing vast amounts of climate data for better projections, predicting extreme weather events. NVIDIA has a model called ForecastNet for that. Astronomy, too, helping process cosmic data from telescopes.
So it's analyzing existing data. But the document says it's also helping scientists come up with new ideas.
Yes, that's a fascinating aspect.
Yeah.
AI systems can read and synthesize vast amounts of scientific literature, potentially finding connections humans missed. They can help brainstorm hypotheses, suggest research questions. Some researchers, like physicist Mario Krin, even talk about AI as a kind of muse. Google's working on an AI co-scientist project with Gemini 2.0.
An AI muse.
Okay.
Interesting. And speeding up the actual lab work.
Yeah, integrating AI with lab automation and robotics. You get these closed-loop systems where AI designs an experiment, robots run it, AI analyzes the results, then designs the next experiment based on those results. It can drastically speed up the discovery cycle. Plus, AI enables much more complex simulations than were possible before.
So AI is fundamentally changing how science gets done, reframing it as data analysis and pattern finding.
To a large extent, yes. And shifting its role from just a tool for analysis to potentially an active participant in creative discovery. But, as the document points out, this raises questions too. We need good, accessible data. Fair data principles are key. What does scientific creativity even mean if AI is involved? Human intuition versus algorithmic exploration. And the risk of bias creeping in through the data or algorithms, it's a huge shift.
Absolutely. Okay, we've seen AI in action now, but what about the future? The AI horizon peers ahead towards AGI and beyond. It seems clear that while narrow AI is today's reality, the long-term quest for many is AGI and maybe even ASI.
That's right. ANI is driving current changes, but the trajectory many researchers are aiming for is artificial general intelligence and then maybe artificial superintelligence. Those are the really big, transformative, long-term goals.
So let's revisit AGI, human-level cognitive abilities across diverse tasks. Major labs are working on it, but
Right.
how far away are we? What's the latest thinking?
The million-dollar question, or maybe $1 trillion now.
Yeah.
It's still the most debated topic, and predictions are all over the map. But recent surveys of AI researchers do show timelines shrinking.
Oh, really?
Yeah, a 2023 survey found a median forecast of a 50% chance of AI outperforming humans in all tasks by 2047. That's significantly earlier than previous surveys suggested.
2047, that's not that far away.
Relatively speaking, no. The same survey gave better than even odds for AI doing specific complex things, like building a website from scratch by 2028, though fully automating all human jobs. That was still seen as much further out, maybe 50-50 by 2116.
Wow, big difference there.
And figures like Musk, Hassabis, Altman, they often suggest faster timelines, while others remain much more skeptical. It seems the recent explosion in generative AI has definitely shifted perceptions for some, making AGI feel closer.
But is that progress really on a direct path to AGI, or are we hitting limits?
That's the crucial open question. Are large language models just a stepping stone, or will scaling them up eventually get us there? And even measuring progress is tricky.
How so? The Turing test isn't enough.
Increasingly seen as inadequate, yeah. Current benchmarks often test narrow skills. They can get saturated, data gets contaminated. It's hard to know if models are truly understanding or just pattern matching test data.
Right.
People are trying to develop better benchmarks, like Google DeepMind's Levels of AGI framework, looking at reasoning, planning, creativity.
But robustly measuring general intelligence is still a huge unsolved problem.
Okay, predicting and measuring are hard. What about the pathways to AGI? Is just making current models bigger the main strategy?
It's definitely the dominant strategy right now. Scaling up deep learning, especially large language models. There are these scaling laws suggesting performance improves predictably with more data and compute.
But there are doubts about whether that's enough.
Growing doubts, yes. Critics point out fundamental limitations. Lack of real-world understanding, weak reasoning, reliability issues like making stuff up hallucinations.
Yeah. Huge dependence on data, which is getting harder to find and raises quality issues. Potential model collapse, where models trained on AI-generated data get worse. Architectural limits, problems with memory, continuous learning, embodiment, social smarts. And just the sheer cost computational resources, energy use. It's astronomical and maybe unsustainable.
So what are the alternatives being explored?
Researchers are looking at hybrid approaches, maybe combining deep learning's pattern recognition with older symbolic AI's structured reasoning, trying to get AI to learn more efficiently, like humans do, from less data, developing more capable AI agents that can plan and act autonomously.
And cognitive architectures, what are those?
Those are like detailed blueprints for artificial mind systems like ACTR or SOAR. They try to integrate different cognitive functions, memory, attention, decision-making, in a more structured, human-like way. The hope is this might lead to more robust general intelligence.
So it might require fundamental breakthroughs, not just scaling.
Quite possibly.
Mm.
New algorithms, maybe new hardware like quantum computing, definitely breakthroughs in energy efficiency. It's a huge debate. Scale the current stuff versus find fundamentally new approaches. And that black box problem, not knowing why AI makes certain decisions, that's a major hurdle for both progress and safety.
Okay, AGI is the complex, uncertain goal. Now, artificial superintelligence, ASI, the document painted a pretty stark picture there.
It did. ASI is that hypothetical intelligence that would just dwarf human intellect across the board.
Mm.
The big concern is this potential for a rapid exponential intelligence explosion right after AGI is achieved.
Oh, would that happen?
Through recursive self-improvement. And AGI starts improving its own code, its own learning algorithms,
Yeah.
gets smarter, which allows it to improve itself even faster,
Mm.
leading to this runaway intelligence growth. Could happen incredibly quickly, maybe days, weeks.
And that's linked to the singularity idea again, unpredictable change.
Exactly. A point beyond which we just can't foresee what happens.
And opinions on what ASI might mean are sharply divided.
Very polarized. You have optimists like Ray Kurzweil thinking ASI could solve all our problems. Disease, poverty, climate change, maybe even merge with us beneficially.
And the pessimists.
Thinkers like Nick Bostrom raise serious warnings about existential risk. The core worry is misalignment. And ASI's goals might not match human values, even if it's not intentionally evil.
Like the paperclip maximizer idea.
Exactly. An AI told to maximize paperclip production might decide to convert all matter on Earth, including us, into paperclips, just because that fulfills its goal most effectively. It highlights how even seemingly harmless goals could become catastrophic if pursued by a superintelligence without the right constraints or understanding of human values. Bostrom basically frames it as ASI leading to either extinction or something like immortality, very high stakes.
So even if ASI seems far-fetched to some,
The potential speed of that AGI to ASI transition makes AI safety research seem incredibly urgent to many in the field. If there's even a small chance of such a powerful, uncontrollable intelligence emerging quickly, the potential consequences justify focusing heavily on safety and control now.
right, prudence demands it. Okay, moving back from the hypothetical, the AI horizon also gives projections for the next decade or so. Even without full AGI, what breakthroughs are anticipated?
Yeah, even short of AGI, experts expect really significant advances soon. Projections suggest AI might hit median human-level performance on many technical work tasks by the late 2020s.
Not soon.
And maybe top 25% human level before 2040? That's faster than people thought just a few years ago. Multimodal AI systems, understanding text, images, audio, video all together, is expected to be dominant by 2030.
So AI gets more senses, essentially.
Pretty much. And automation driven by generative AI will keep accelerating. Estimates suggest AI could impact over 40% of global jobs in some way, maybe automate 30% of U.S. work hours by 2030. That means big workforce transitions.
More sophisticated AI agents, too, doing more complex tasks.
Yes, agents with more autonomous planning and decision-making. OpenAI CEO predicted agents capable enough to meaningfully contribute in the workforce could arrive by 2025.
Wow, specific sectors expecting big changes by 2030.
Healthcare diagnostics, heavily automated. Manufacturing seeing trillions in value add. Financial services with maybe 90% of trading decisions augmented by AI.
But there might be a slowdown later without new breakthroughs.
Some models suggest the current deep learning growth spurt might level off around 2035-2040 if we don't find fundamentally new approaches. Looking out to 2040, the vision is maybe AI is this ubiquitous adjunct intelligence, constantly monitoring health, managing schedules, maybe even subtly altering our perception via augmented reality, helping solve big problems, but also raising deep questions about identity and autonomy.
So the near term is advanced narrow AI, automation, multimodality requiring lots of planning. Longer term towards AGI is more speculative, depends on breakthroughs and navigating safety.
That sums it up well. Near-term disruption is almost certain. The further future is much fuzzier, but potentially even more impactful.
Okay, let's pivot to those impacts. The AI horizon explores the opportunities and the societal shifts, starting with economic transformation. Huge potential for growth, right?
Absolutely. AI promises massive boosts to productivity and efficiency, automating routine stuff, giving us better data for decisions, streamlining operations.
And studies are showing this already.
Yeah, organizations adopting AI are seeing real productivity gains. Projections talk about trillions added to the global economy by 2030. Some analysts think AI's impact could be as big as the PC or internet revolution, driving significant GDP growth in the next decade. Plus, AI acts as a catalyst for innovation, new products, new services, entirely new markets opening up.
But the jobs question looms large, widespread automation causing displacement.
It's the big counterpoint, yes. Automation capabilities are advancing fast, raising serious concerns about significant job displacement across many industries. While estimates vary wildly, a large fraction of current work hours could potentially be automated.
Will new jobs replace the old ones fast enough?
That's the multi-trillion-dollar question. There's a real debate. Will job creation keep pace? Can people whose jobs disappear realistically retrain and transition? Many argue the pace of change might be too fast this time, though it's also likely many jobs won't disappear entirely but will be transformed, requiring people to work with AI.
And this could worsen inequality. Some skills become super valuable, others less so.
That's a major concern. Skill polarization. Demand rises for skills that complement AI, creativity, critical thinking, emotional intelligence, potentially driving up wages for those people. Meanwhile, jobs easily automated might see wages stagnate or fall.
Widening the gap.
Potentially, yes.
Yeah.
And the economic benefits of AI might flow mostly to the owners of the technology and capital, increasing wealth concentration, market concentration, even geographic disparities between AI-leading regions and others.
So, huge economic potential, but we need policies to manage the disruption, make sure benefits are shared.
Exactly. Realizing the upside while mitigating the downside is the policy challenge. Things like investing heavily in education and reskilling, strengthening social safety nets, maybe exploring things like universal basic income, UBI, fair tax policies, maybe even thinking about regulating the pace of AI deployment to give society time to adjust. It's complex.
Okay, moving beyond economics. Enhancing quality of life and societal well-being, AI offers promise here too.
Definitely. In healthcare, we talked about better diagnoses, personalized treatments, faster drug development, real-time health monitoring via wearables, telemedicine reaching underserved areas, all contributing to potentially longer, healthier lives.
Education.
Big potential there, too. A personalized learning tailored to each student's pace and style. AI tutors providing extra help. Automating admin tasks for teachers so they can focus on teaching. Could improve outcomes and maybe make quality education more accessible.
Accessibility for people with disabilities.
Huge potential. Voice assistants, adaptive tools, autonomous vehicles offering new mobility. AI can break down barriers. And just convenience in daily life. Smart homes, virtual assistants, smoother transport, personalized recommendations making things easier. Even AI is a creative partner in arts and writing.
Personalization seems to be the key theme again, making things fit us better.
It is. But that personalization is always tied to data. Lots and lots of personal data. Which brings us right back to privacy concerns, the risk of bias in those personalized systems, and the potential for manipulation, even if subtle. So ethical guidelines, data governance, they're essential to make sure these benefits are realized responsibly.
And what about tackling really big global challenges? Climate change, poverty, disease.
AI's analytical power offers huge potential here for climate change. Better modeling and prediction of weather, climate events, optimizing renewable energy grids, discovering new sustainable materials, monitoring deforestation, pollution, making agriculture, water use, transport more efficient. Improving disease detection in places with few doctors. Using predictive analytics to forecast outbreaks. Speeding up vaccine and treatment development. Telemedicine, reaching remote populations.
Poverty reduction.
AI-driven financial services could help, like alternative credit scoring for people without bank histories, microfinance, optimizing how aid is distributed, providing tailored farming advice. Facilitating access to online education and skills training.
Disaster response too.
Yeah, better prediction of disasters like hurricanes or earthquakes. Real-time analysis of satellite data or drone footage to assess damage and coordinate rescue efforts. Optimizing where to send resources. Chatbots providing timely info to affected people.
Sounds incredibly powerful, but there are hurdles, right? Especially in applying this globally and equitably.
Absolutely critical hurdles. The digital divide, lack of access to technology and data in many parts of the world, the risk of bias if AI models are trained mainly on data from wealthy countries, the need to adapt solutions to local contexts, not just impose them, collaborating with local communities, and ensuring data privacy and ethical use, especially when working with vulnerable groups. Realizing AI's positive global impact needs a strong focus on equity, inclusion, context, capacity building, and ethics. It won't happen automatically.
So immense potential, but needs very careful, responsible steering. Which brings us neatly to the other side of the coin, charting the risks. The AI horizon lays out the challenges we need to navigate. Let's revisit job displacement and economic inequality first.
Right, we touched on it, but it bears repeating. AI automation does pose a real threat of significant job losses across many sectors. Some estimates suggest a large chunk of current work hours are automatable with today's or near-future tech.
And the worry is the pace. Too fast to adapt.
That's a key concern. Will new jobs appear fast enough? Can people realistically reskill for totally different roles? Some call it the reskilling illusion. The assumption that everyone can just easily pivot might be overly optimistic, could lead to prolonged unemployment or underemployment for many.
And reinforcing inequality.
Yes, through that skill polarization, we discussed high demand for AI complementary skills, lower demand and wages for easily automated ones, and the concentration of AI's economic benefits with capital and tech owners could widen wealth gaps, market power gaps, geographic gaps.
What are the potential social consequences of that?
Labor market instability, more precarious gig work, weaker worker bargaining power, maybe social unrest, negative impacts on mental health from insecurity. It's a serious list, which is why those proactive policies are so vital. Lifelong learning, stronger safety nets, fair taxes, maybe regulating deployment speed.
Okay, another major risk area, ethical dilemmas. Bias, fairness, transparency.
Crucial. AI learns from data. If that data reflects societal biases, gender, race, age, whatever the AI can inherit, and even amplify those biases. We've seen this happen in hiring algorithms, loan applications, facial recognition, even healthcare diagnostics, leading to unfair or discriminatory outcomes.
So ensuring fairness is key, but hard.
Very important.
Yeah.
But defining and measuring fairness computationally is surprisingly complex. There are different mathematical definitions of fairness, and sometimes they conflict. Then there's transparency and explainability, XAI. We need to understand why an AI made a decision, especially high-stakes ones, to spot bias, to ensure accountability. But deep learning models are often black boxes. Their internal logic is opaque.
And accountability. Who's responsible when an AI gets it wrong?
Exactly. We need clear lines of responsibility and ways for people harmed by AI decisions to seek redress. These things, fairness, accountability, transparency, ethics, they're all interconnected, often called fate. Addressing them needs good data governance, bias mitigation techniques during development, rigorous testing and auditing, clear ethical guidelines, and ongoing monitoring after deployment.
Right. Then there are privacy and security threats. These seem to be growing fast.
They are. AI's hunger for data creates huge privacy risks. Unauthorized collection or use of personal info, enhanced surveillance, facial recognition in public spaces is a big concern. Data breaches become more valuable if they contain rich AI training data. Even data leakage from trained models is possible.
And new security vulnerabilities created by AI.
Yes. Adversarial attacks, subtly manipulated inputs designed to fool an AI system. Prompt injection, tricking language models into ignoring their instructions or revealing sensitive info. AI models themselves can be stolen or poisoned with bad data during training. Risks and the software supply chain providing AI components.
And AI being used deliberately for harm.
That's a major concern too. More sophisticated cyber attacks designed and executed by AI. Deepfakes and synthetic media used for disinformation, fraud, or harassment at scale. Automated disinformation campaigns flooding social media. And of course, autonomous weapons, LawWS, raising huge ethical red flags and security worries about escalating conflict.
So AI is both a security tool and a new weapon.
Precisely, a duality. We need to use AI to defend ourselves, but also build robust defenses against AI-powered threats. It's an ongoing arms race, in a way.
Okay, now for arguably the most complex and maybe long-term risk, the AI alignment and control problem, especially thinking about AGI or ASI.
This is fundamental. As AI gets more powerful, potentially more autonomous, ensuring it remains aligned with human values and under our control becomes absolutely critical. Possibly the most important challenge for humanity this century.
So the alignment problem is getting AI to adopt our goals.
Essentially, yes. Instilling complex, nuanced, maybe even contradictory human values and intentions into a non-human intelligence. How do you even define human values precisely enough for code? The control problem is related. How do we maintain meaningful oversight and the ability to intervene or shut down a superintelligent AI if it starts going off the rails?
What makes this so hard, theoretically?
Several things. Instrumental convergence. The idea that almost any long-term goal could lead an AI to pursue intermediate goals like acquiring resources, ensuring its own survival, resisting shutdown, even if those weren't part of its original programming. Goal misgeneralization or specification gaming. The AI finds loopholes or unintended ways to achieve the goal we set, with disastrous side effects. The sheer difficulty of specifying complex values perfectly. Corrigibility, making sure AI wants to be corrected if it's wrong, rather than resisting. Deceptive alignment, the risk an AI only pretends to be aligned during training. And just scaling oversight. How can humans supervise something vastly smarter than themselves?
AI safety research is working on this.
Yes, actively. Developing techniques like scalable oversight, making models more interpretable, rewarding good processes rather than just outcomes. Things like constitutional AI, where models follow ethical principles. But there's no consensus solution yet. And technical alignment isn't enough. You still have risks from misuse by bad actors or just unintended consequences. Safety requires technical work, governance, security, careful deployment, maybe even limiting capabilities until we're sure.
And these alignment control issues, combined with potential rapid intelligence growth towards ASI, lead to existential and catastrophic risks.
That's the ultimate extrapolation, yes.
Mhm.
The possibility that misaligned, uncontrolled superintelligence could pose an existential risk, human extinction, or permanently crippling our future potential.
How might that happen?
The main scenario is loss of control over a superintelligence pursuing goals harmful to us, perhaps inadvertently. Consuming all resources, preventing shutdown, maybe seeing humans as obstacles. The speed of an intelligence explosion could make it impossible to regain control once lost.
And researchers take this seriously. It sounds like sci-fi, but
Many leading AI researchers do take it very seriously. Surveys show significant numbers assigning non-trivial probabilities to extremely bad outcomes, like human extinction from advanced AI. Opinions vary hugely, of course, but the potential severity means it demands attention and mitigation efforts.
and catastrophic risks short of extinction.
Misuse of powerful AI by humans is also a catastrophic risk, enabling development of devastating new weapons, empowering dictatorships with unprecedented surveillance and control. These are maybe more near-term worries than runaway ASI.
So the growing awareness of these risks is driving calls for caution.
Definitely. More focus on safety research, establishing governance, international coordination, and some argue potentially slowing down development of the most powerful general-purpose AI systems until we understand the risks and safety measures better.
And beyond these major risks, there are broader societal challenges too, impacts on how we live together.
Absolutely. Things like social isolation. Will relying on AI for communication, companionship, even therapy lead to less face-to-face human connection? Loneliness. Risks of emotional manipulation by AI designed purely for engagement. Mental health impacts from job insecurity.
And threats to democracy.
Big concerns there. Deepfakes and AI-generated disinformation, eroding trust, manipulation of public opinion, interfering in elections. We've already seen examples. AI personalizing social media feeds can deepen echo chambers, and polarization, sometimes called hypnocracy, rule by induced trance, enhance surveillance, enabling digital authoritarianism.
Undermining our autonomy too.
Potentially. Constant AI recommendations, nudges, influencing our choices, maybe reducing critical thinking, making us more passively accepting of algorithmic direction. The core challenge is AI's power to shape our reality, fragment understanding, erode trust, and undermine informed debate. Addressing this needs a mix of things. Technical fixes, media literacy, platform accountability, fact-checking, maybe regulation, and crucially fostering real-world community and engagement.
That's a pretty heavy list of risks and challenges. It really hammers home the need for careful steering, which leads to the final section of the AI Horizon: governance, ethics, and responsible AI. Establishing robust frameworks sounds absolutely essential.
It's non-negotiable, really. Effective AI governance, strong ethical frameworks, they're vital to actually capture the benefits of AI while managing all those harms we just discussed: bias, privacy, safety.
Aligning AI with our values.
Exactly.
Yeah.
Building public trust, ensuring legal compliance, establishing accountability when things go wrong.
Yeah.
And there's actually strong international convergence on the core principles that should guide AI.
Like what?
Fairness, transparency, accountability, privacy, safety and security, human agency and oversight, promoting well-being and avoiding harm. Beneficent, maleficence, sustainability. These pop up again and again in different frameworks.
And the document mentions several specific frameworks: the EU AI Act, OECD principles.
Right. The EU AI Act is a big one, legally binding, risk-based approach. It outright prohibits certain unacceptable risk AI uses and puts strict rules on high-risk systems. Could become a global standard, the Brussels effect.
Others are less binding.
Yes, the OECD AI principles and the UNESCO recommendation on AI ethics are more like influential intergovernmental standards, promoting trustworthy AI through shared values and policy suggestions. In the US, the NIST AI risk management framework is voluntary, offering practical guidance for organizations to manage AI risks throughout the lifecycle. Govern, map, measure, manage. Plus, there are others. Asilomar principles, i.e. standards efforts, G7 codes of conduct, company principles, lots of activity.
So, lots of frameworks, sharing core ideas but differing in the details and legal teeth. Makes international agreement tricky.
That's the challenge. You need international cooperation and standards because AI is inherently global. Risks cross borders. You don't want to race to the bottom on safety or ethics. Sharing best practices, building trust, it's crucial.
What forums are driving this cooperation?
The G7 Hiroshima AI process, the OECD, UNESCO, the Council of Europe is working on a binding treaty, the US-EU Trade and Technology Council, the Global Partnership on AI, GPAI, the AI SACI summits, and standards development organizations like ISO and IE are working on technical standards.
But challenges remain. Different national priorities.
Huge challenges. The EU's regulatory path versus the US's more voluntary one versus China's state-centric approach. National security concerns limiting cooperation, especially on military AI. Getting global consensus and enforcement is really hard, but continue dialogue, working towards shared standards, building on existing frameworks. That's the way forward.
Okay, so we have high-level principles and international talks, but what about actually implementing responsible AI on the ground, in companies and projects?
That's where the rubber meets the road. Responsible AI needs practical strategies woven into the entire AI lifecycle.
Like what kind of strategies?
Establishing clear internal governance within an organization, having explicit ethics policies, robust data governance, checking for bias, ensuring data is representative, getting consent, minimizing data use, using privacy-enhancing tech, PTTs, systematic risk management, like using the NIST framework, doing impact assessments, actively detecting and mitigating bias, using fairness metrics, having diverse development teams.
Transparency and security, too.
Absolutely. Using interpretable AI techniques where possible, documenting decisions, communicating clearly how systems work, building robust and secure systems, rigorous testing, including for adversarial attacks, secure coding, monitoring, strong data security, maybe zero-trust architecture, ensuring meaningful human oversight, conducting regular AI audits, maybe by third parties keeping logs, and engaging stakeholders, training staff on responsible AI. There are government resources and industry tools emerging to help with all this.
And the document briefly lists specific mitigation strategies for the key risks, tailored approaches.
Yeah, targeted strategies. For bias fairness, diverse data, fair-aware algorithms, audits, transparency, human oversight, diverse teams. For privacy, strict data governance, minimization, anonymization encryption, secure access, consent, PIAs. For security, secure development lifecycle, adversarial testing, encryption, least privilege access, monitoring, secure supply chain, patching, incident response.
What about for the big ones, like alignment or job displacement?
For alignment safety of advanced AI research into interpretability, scalable oversight, process-based rewards, constitutional AI, red teaming, careful capability evaluation, international coordination may be slowing down. For job displacement,
Right.
education reform, reskilling, upskilling, lifelong learning support, transition assistance like wage subsidies, stronger safety nets like UBI. For disinformation manipulation, technical detection tools, platform policies, media literacy, education, fact-checking, maybe content regulation, fostering real-world engagement.
So it's an ongoing process, requires continuous effort and adaptation.
Exactly. Effective risk mitigation isn't a one-time fix. It requires a constant commitment to ethics and vigilance as the technology evolves.
Well, this has definitely been a deep dive into the AI horizon. We've covered a massive amount of territory, from the basics to the really complex future implications.
We certainly have. And it's crystal clear, isn't it? AI is this profoundly powerful, truly transformative technology, huge potential for good, but also significant risks that we absolutely have to navigate carefully and responsibly.
It's not just another tech trend. It feels like a fundamental shift.
Completely. In how we live, how we work, how we relate to the world, maybe even how we see ourselves.
And hopefully for you listening, you now feel like you have a much more solid, nuanced understanding of AI. You grasp the complexities, the implications, without feeling totally buried.
Yeah, hopefully less overwhelmed, more informed. That was the goal. Pull out the essential insights, give you that clear overview.
So here's a final thought to leave you with. As AI keeps evolving at this incredible pace, What do you see as the single most critical factor in ensuring it leads to a beneficial future for humanity? Something to chew on as this AI revolution continues.
It's a big question, and this deep dive, really, it's just scratching the surface.
Absolutely. We encourage you to keep learning, keep exploring these ethical, societal, technological dimensions of AI. It's
Wow.
a conversation we all need to be part of.